So in this video of chapter number 7, triangles, we're going to discuss a very important concept, and that concept is criteria for congruence of triangles. So in the previous video, we saw that what exactly is the meaning of congruency of triangles. Two triangles are congruent when they're exactly equal to each other, when all their three sides and all their three angles are equal to each other. That time we say that the two triangles are congruent to each other. However, we'll now see in this video that in order to prove that if two triangles are congruent or not, we need not check all the three sides and all the three angles. That is total 6 parameters that we have to check. But every time, in order to prove the congruency of two triangles, we need not check for all the 6 parameters. Sometimes only 2-3 parameters will also prove that two triangles are congruent to each other. So let's see what are these criterias. What are these criterias for congruence of triangles? Now, to be more specific, there are total 4 criterias. So I'm going to move this. Yes, I'm going to move this here. Okay, because I missed writing that. In fact, there are, let me use a different color. There are 4 criterias. Okay, there are 4 different criterias for congruency of triangles. So let us see all 4 of them. Let's start with the first one. The first criteria is called SAS congruence rule. So let's try to zoom in. SAS congruence rule. So what does SAS stands for? So S stands for side. Okay. A stands for angle. And again, this S also stands for side. So this congruence rule is called as SAS, side angle side congruence rule. What does it mean? Very simple. Let us draw a triangle here. So let's say this is my triangle, and I'm going to create a copy of this triangle. Copy and paste. Okay, so these two triangles are obviously congruent to each other because I've created a copy of them. Now, that's not how we should think about it. The way I want you to think about this is, if I give you two triangles A, B, C, so let me name them A, B, C, and this triangle is P, Q, R. Okay, and if I tell you that AB is congruent to PQ, okay, and BC is congruent to QR, okay, and the angle in between these two sides, AB and BC, PQ and QR, the angle in between these two sides is also congruent to each other. Okay, so note that this is side angle side, side angle side. Okay, so in these two triangles, any two random triangles ABC and PQR, if I tell you that a side angle side, side angle side are equal to each other, then we can say that triangle ABC is congruent to triangle PQR. No need to check other parameters. The other length of the side, the other measure of these angles are totally irrelevant. There is no need to check for them. Hence, this congruence rule is called as SAS, which is side angle side. All we need is only 3 parameters. Now, one key point in this is that the angle has to be between these two sides. Okay, this angle has to be between these two sides. You cannot use this congruence rule by saying that these two sides are equal and this is the angle which is equal to you. Okay, let me clarify this point by erasing this. Okay, now let's say, yeah, this is a triangle. Okay, let's say we have these two triangles. Okay, ABC and PQ are given to you, and AB is equal to PQ and BC is equal to QR. And if I tell you that this angle, okay, angle A is equal to angle P. Now, this does not fall under SAS rule. In SAS rule, the angle should be between these two sides. It should be included between these two sides. If the angle is somewhere else, then you cannot apply SAS rule. So that is a very important point. SAS congruence rule. So I think I have formally noted down the definition of SAS rule here. Let's go through it. Yes. So what does it read? Two triangles are congruent if, let me use a highlighter, if two sides and the included angle are equal to two sides and the included angle of the other triangle. Now, the most important word in this description is the included angle. Included angle. Okay, that's the point I was stressing about a while ago, that this included angle has to be equal between these two sides, not any random other angle. So that is SAS congruence rule. Now, there's an important point which we should note about it. that SAS congruence rule holds, okay, but not, so I'm going to fill in the blanks, not SSA or not ASS. Okay, again, very important. That's the point I was stressing about, that this angle A has to be between the two sides. It cannot be in the side or it cannot be in the beginning. So SAS only holds, not SSA or ASS. So that's an important point about this first criteria. We want to see all the four criteria. This is the first criteria of congruence, SAS, side angle side. Let's quickly go to the next one. So the next or the second rule of congruence is called AAS. Now once again, no surprise here. What does this stand for? A stands for angle. Okay. The second A also stands for angle, and the third S stands for side. AAS congruence rule. So once again, what can I copy this? Okay. Let me write or create new angles, new triangles. Okay, so this is my triangle. Okay, and I'm just going to create another triangle. Let's say I tell you in these two triangles, if I tell you that this angle is equal to this angle and this angle is equal to this angle and this side is equal to this side. Okay, so I have not named the triangles, but I mean it's fine, we need not name it. So in these two triangles, I am telling you that there are two angles which are congruent to each other and there is one side which is congruent to each other. If that is the given information, then again we can very confidently say that these two triangles are congruent using the AAS rule, angle, angle, side. Now, an important difference between this rule and the previous rule is that the AAS thing is not, I mean this order is not a very strict order. So for example, if SSA or S or ASA, all these rules are also valid. Any two angles and a third side, any two pair of angles and the third side are congruent to each other, then we can say that the two triangles are congruent to each other. This is different than the previous rule. In previous rule, the SAS order is very strict. You cannot go for this. But this is not the case in the second rule, thankfully. So that is the point I think I have noted down here. Let's go through it. Yes, let me zoom out. Yeah, so let's read it. Two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. We may call it AAS congruence rule. Again, the keyword here is any two. Okay, it's looking quite bad. So okay, I'll just, this is the keyword, any. Okay, any two pair of angles and one pair of corresponding sides should be equal. So either you can go with these two pairs, okay, or you can even go with these two pairs, or you can even go with these two pairs of angles. So any two pair of angles and one side is congruent. That's all. You can say that the two triangles are congruent using the AAS congruence rule. Very flexible. So this was our second criteria in the total 4 criteria of congruence triangles. Now the third one, which is quite simple and the straightforward and the most easiest one, it's called SSS congruence rule. So oops, let's zoom in. Yes, so once again, this SSS, nothing but it stands for side, side, side. Okay, so once again, this is I think very obvious and very intuitive, the most intuitive congruence rule. If the sides of 3 triangles are equal, then obviously the 3 triangles are equal to each other. So once again, I am going to take 2 random triangles and I'm going to say this side, okay, this side is congruent to this side, then I will say this side is congruent to this side, and then I will say this side is congruent to this side. So if 3 sides of a triangle are equal to 3 sides of another triangle, then we say the triangle is congruent based on SSS rule. So quite simple and straightforward. I think we have a formal definition here. Let's go through it. Yes. So yeah, let's read it out. If 3 sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent. So this is our third and I think the most simplest and the most obvious congruence rule. So once again, these congruence rules are the rules which help us to determine if two triangles are congruent or not. And in this, by using these rules, we need not check for all the 6 parameters. All 3 angles and 3 sides, we need not check for all these total 6 parameters. Any 3 parameters and we are done. Now the fourth and the last rule of congruence rule is called as RHS congruence rule. So once again, let me write the full form. R stands for right angle. This is specifically for right angle triangles. Okay. H stands for hypotenuse. So we know in right angle, the longest side is called as hypotenuse, and S stands for side. Okay. Right angle hypotenuse side congruence rule. What does this mean? Now, as the name suggests, this is specifically for a right angle triangle. So I'm going to draw one right angle triangle here. Okay, and I want to draw another right angle triangle here. Now, this rule says that two right angle triangles, so hold on, let me first mention this. This is the right angle here. Yeah. So it says that the two right angle triangles are equal if, now, if there's a right angle, so right angle I have mentioned, and hypotenuse are equal to each other. So this hypotenuse should be equal to this hypotenuse, and then any side, one side is equal to the other side. So it can be this side, so or it can be this side. I'll just put 3 lines. Okay. So I think this will be more confusing. Let me just stick to one side first. So two right angle triangles are congruent to each other if, so obviously right angle is always there because we are talking only about right angle triangles. So no need to consider this. We only need 2 information. One is the hypotenuse length. So the hypotenuse should be equal to each other, and any side, either this side or this side, should also be equal to each other. In that case, using the RHS congruence rule, we can say that the two right angle triangles are congruent to each other. So once again, I think there's a formal definition here. Let's go through it. Yes. Okay. So if in two right triangles, the hypotenuse and one side of one triangle are equal to hypotenuse and one side of the other triangle, then the two triangles are congruent. Okay, quite simple and straightforward, I think. Note that RHS stands for right angle hypotenuse side. A little bit lengthy name as compared to the previous 3, but yeah, that's how it is. So with this ends all the 4 criteria to check the congruence of triangles. We are going to do a quick revision here, what we saw in this video. So let us list 4 criteria for congruency of triangles. So I'm going to quickly note them down. The first one was SAS. The most important thing about this SAS rule is the order. It has to be side, angle, side. You cannot change the order. The second one we saw was AAS. In this, the order doesn't matter. Any 2 pair of angles and 1 side. Then the third one was SSS. All 3 sides of triangle. If they are equal, then the triangles are congruent. And the fourth one was right angle hypotenuse side. So these are the 4 criteria of congruence of triangles. Very important. Using these 4 criteria, we are going to solve many exercise problems. We have to use, you should be able to understand which of them we have to use while solving the problem and prove that any 2 triangles are congruent. That's it.